Hello everyone. Today's topic is Chapter 1, which is part of the Inorganic Chemistry, and the name of the chapter is Chemistry of the Representative Elements. We are going through the introductory part today. This is a pictorial representation of the periodic table. The smartest and easiest way to memorize any topic is through its pictorial representation. In this picture, you can see that on the left hand side, we have the S block. On the right side, we have the P block. And in between S and P, we have the D block. This upper body. So below this upper body, we have the F block. So you get this question in your MCQs for 1 mark, which is the multiple choice question, that what is the location of the S block on the periodic table? So you can tick or choose the correct option. It is on the extreme left. If I ask what is the position of the P block on the periodic table, you can easily say that it is located on the extreme right. For D block, it is middle, and for F block, it is below the main body. You get this in your multiple choice question answers for 1 mark to tell the location of the block on the periodic table. Talking about the periodic table, it is the systematic arrangement of the elements in such a way that they are arranged on the basis of their increasing atomic number. And what does this mean? That the number of proton is increasing. Eventually, if the number of proton is increasing, the number of electrons will increase. And from that atomic number, we write the electronic configuration, which describes the properties of that particular element. Periodic table is further classified in 7 horizontal rows as the periods and 18 vertical columns, that is the group. The groups are further divided into subgroup A and subgroup B. Subgroup A consists of the representative elements. In representative elements, we have 2 blocks, which is S and P block. Representative elements are also called as the typical elements or the elements that are located in the S and P block. For subgroup B, we have 2 blocks, that is the D and F block. That is, we are considering the middle and the lower part of the main body. Now, what is a block? Block is the specific section that we have in the periodic table which shows the type of orbital that is being filled by the outermost electrons. For example, we have S block. The name itself says the block is S. It means the outermost electron will be present in the S orbital. We know that S block is on the extreme left. It includes 2 groups, which is group 1A, alkali metals, and group 2A, which is alkaline earth metals. Since the block consists of the orbitals, S orbitals, and S orbital contains maximum 2 electrons. So the valence shell configuration for the S block will be from ns1 to ns2. It means the minimum electrons the S orbital can have is 1 and the maximum electron is 2. For the P block, the valence electrons are present in the P orbital. It is located on the extreme right. The p orbital contains maximum electron 6 and the minimum it can have 1 electron. So the valence configuration will be ns2, np1, 2, ns2, np6. The s is constant with maximum of 2 electrons. The s orbital is filled first and then the electrons will move to the p orbital. The d block, which is located in the middle in between the s and p block. In d block, we have d orbital. In d orbital, we can have maximum 10 electrons. So the valence electronic configuration is ns2, n-1, d1, 2 ns2, n-1 d10. N is the number of the shell. The electron is present in which shell? It can be 1, 2, 3 till infinity. N-1 shows the penultimate shell. Penultimate shell means the second last shell. F block, which is below the main body. In F orbital, we can have a maximum of 14 electrons. So the valence shell configuration will be ns1, 2, n-2, f1 to ns1, n-2, f14. The F block comprises of two series and each series contains 14 elements. It means it has a total of 28 elements. The series are named as lanthanide and actinide series as per their starting element. So the periodic table is the systematic arrangement. It has 7 horizontal rows, 18 vertical columns, which is the group. Group is further divided into subgroup A and subgroup B. We have 4 blocks in the periodic table, which shows the location of the valence electron in the orbital. We have S, P, D and F orbital. If the orbital is S, it means we are talking about the S block. If it is D, D block is concerned. You mostly get this question in your multiple choice question in which they ask you to choose the correct option for the valence shell configuration of a particular block. Or you might get a 1-mark definition of the periodic table. Let's move further. Electronic configuration. Not only it tells you the properties of that particular metal, but it also identifies the position of each element in the group, period and block. And how it does that? We are going to study this with the example as well. So in electronic configuration, we have the same scenario for the periods and the groups. N is the principal quantum number, where group is depicted by the number of electrons in the valence shell. For example, we have sulfur and the atomic number of sulfur is 16. Atomic number is denoted by a capital Z. So we write the electronic configuration, which is 1s2, 2s2, 2p6, 3s2, 3p4. Here you can see that the principal quantum number, the energy level, the numeric value which is highlighted with the red one is 3. It means sulfur belongs to period third. And if you watch closely, the third energy level has 2 orbitals, which is S and P. It shows 3s2 and 3p4. It means the period is third and it consists of 2 orbitals S and P. So all these orbitals containing electron, we will sum these electrons because the third energy level has 2 orbitals S and P. So the summation will give us 4 plus 2 is 6. So the period is third and the group is 6A. Next topic that we will have will be the group trend, and we will study this in the next session. Meanwhile, if you have any query, you can reach out and feel free to ask and drop down the questions in the comment section. Thank you.